friends, welcome to my channel Interesting Engineering. Today let's discuss about laws of charge method, which is a method meant for measuring high resistance values. Laws of charge method. This is a method meant for measuring high value of resistances and is also used for measurement of leakage resistance of insulating materials and cables. So in this method, we are going to measure the high resistance value as well as the leakage resistances. And in this method, the major component used is the capacitor. So by means of charging and discharging the capacitor, we are going to measure the high resistance value. So first let's discuss about its circuit. So this is the circuit for laws of charge method, where we have a capacitor, and this capacitor is connected to a source by means of a switch arrangement, and when the switch is placed at position 1, it is connected with the battery source by means of a it charge. So after a certain duration, when the switch is moved from position 1 to position 2, this part of the circuit gets disconnected so that the charge present in this capacitor will be discharged through this resistor RS. So in this case, there is a presence of voltmeter here. Here we make use of a electrostatic voltmeter, and this electrostatic voltmeter measures the potential across the capacitor for every time instant. So this is the circuit meant for measuring resistance values, leakage resistances, so using the capacitor method. So in this case, here we have one more resistance represented as RL, which is nothing but the leakage resistance. So normally the capacitor will be having leakage reactance, as well as the electrostatic voltmeter used here will also be having some sort of leakage resistance. So this leakage resistance is the parallel combination of the leakage resistance of capacitor as well as the leakage resistance of the voltmeter. So in the circuit, based on the circuit, so the effective resistance present in this entire circuit is denoted by R effective, which is nothing but the parallel combination of the leakage resistance as well as the unknown resistance. So when we look at the circuit, we have two resistances, Rx, which is the unknown resistance, and RL, which is the leakage resistance. So the effective resistance present in this circuit will be the parallel combination of leakage resistance as well as the unknown resistance. So initially, the switch is placed at position 1, and by means of this voltage source, the capacitor gets charged. So initial charging, let's consider the initial charge of this capacitor for a time period of 0 will be V1. So when this switch changes to the position 2, the switch disconnected, the battery source gets disconnected. So the capacitor, the charge present in the capacitor gets discharged through the unknown resistance. So after a certain time duration, the voltage, take for example time period T, after this time period T, the voltage gets reduced to V2. There will be a drop in voltage from V1 to V2 due to the discharging of capacitor through the unknown resistance RS. So that's what's happening in this circuit. So by means of these, we are going to measure what is the resistance present in this state. So that is nothing but the leakage resistance of this circuit or leakage resistance of insulators. So since we make use of a capacitor here, when it gets disconnected from the battery source, there will be some leakage current flowing through the resistor R effective.
as I said earlier, R effective is nothing but the parallel combination of RL and RX, which is nothing but 1 by R effective will be equal to 1 by RX plus 1 by RL. So as we all know, when two resistors are connected in parallel, the effective resistance will be the reciprocal of the resistance value. So 1 by R effective will be equal to 1 by Rx plus 1 by RL. So when the battery source gets disconnected from the capacitor, the capacitance, the energy stored in this capacitor will be discharged through this unknown resistance Rx. So for our measurement purpose, I'm going to assume the entire resistance of the circuit as R effective, and through this R effective there flows leakage current that is represented by I. So let's derive the equation. So when the switch is at position 1, the voltage is V1, and when the switch changes to position 2, the voltage gradually reduces, and after a certain time duration, when we measure the voltage, it will be some lesser value compared to the value we measured. So based on this, let's derive the equation for R effective. So initially, by means of since we have a capacitor here, we can represent the current as leakage current as dQ by dt. Thus, we have already known the current through any circuit will be the rate of change of charge carrier. That's what I have written here, minus dQ by dt. Here minus sign is here. It's due to it's because here the current has this discharging current, so I'm representing it by minus sign. And when for in the case of Q, we can write it as minus C dV by dt. Since we related is a capacitor, the discharge current will be represented by minus C dV by dt. Let's consider this equation as number 1. And by means of this, remember, current will be the ratio between voltage and the resistance. So what's the resistance here? It's nothing but R effective. So let's consider this equation as number 2, and when we equate these two equations, we get it as V by R effective will be equal to minus K dV by dt. So I'm bringing the dV to the other side, so it changes as V by dV is equal to V by dt, sorry, dV by V is equal to dt by minus dt by C into R effective. So here, the when the time changes from 0 to t, the voltage changes from V1 to V2. So now I'm going to integrate this equation. Since we have a differentiation here, we will integrate it. So since the voltage changes from V1 to V2, the integration limit will be V1 to V2 dV by V is equal to integral. The time here we have difference of time. So the time changes from 0 to t. So the limit will be 0 to t dt by C into R effective. So here, integration of dV by V will be ln of n to the power n, ln of V limit V1 to V2 is equal to integration of dt over C minus C by C into R effective. So when we substitute the limit, it changes that ln of V2 by V1 is equal to minus C by C into R effective. So since here we have ln, I'm going to take logarithm on both sides. Ln is nothing but logarithm of V2. So we get it as V2 by V1 is equal to e power minus t by t into R effective. Now bring this V1 to the other side. So it changes as V2 is equal to V1 into e power minus t by t into R effective. So this is our final equation. So here in this equation, V2 and V1 are going to become the value obtained using this electrostatic potential. V2 and V1 are the voltages that is indicated in the electrostatic potential. T is the time duration. This is also a known factor. T is the capacitance value. The only unknown here will be R effective. So we can able to find out the value of R effective using this equation.
What is needed in our equation is Rx. We need to find out the value of Rx. So to find out the value of Rx, now I am going to open circuit this Rx. So Rx resistance, I am going to eliminate this Rx resistance so that the circuit becomes open circuited. So whatever the charge present in the capacitor will be discharged only through this leakage resistance. So in the same way, when we apply these equations for the resistance RL, we get the equation as V2 is equal to V1 e power minus t by C into RL. So by means of this equation, we could able to find out the value of RL. So we can able to find out the value of RL. So we know the value of R effective and we know the value of RL. So from this equation, 1 by R effective is equal to 1 by Rx plus 1 by RL. So from this equation, we could able to find out the value of Rx. So by means of deriving these values, we could able to find out the value of Rx, which is nothing but our unknown resistance. So this is how we could able to find out the value of leakage resistance or unknown resistance or unknown high value of resistance using this loss of charge method. So in the case of loss of charge method, we are making use of a capacitor, and the capacitor is made to discharge through a unknown value of resistance, and that unknown value of resistance could be found out using the values of voltages represented by this voltmeter and the capacitance value. So this is how we could able to find out the value of unknown resistance, unknown high value of resistance using this loss of charge method. So loss of charge is nothing but we are going to discharge the charge present in the capacitor, charge stored in the capacitor. So by means of which we are going to find out the resistance value. So for when we make use of this method, we must know the value of capacitance and also we must know the values of voltages at every time instance. So this is a more simple and accurate method of measuring higher resistance values, and in the same way we can even apply this method for measuring the insulation resistance of cables also. So to measure the insulating resistance of cables, that too let me explain it now. So as we all know, a cable will be having a conductor. At the center part of the cable we have a conductor, and this conductor is surrounded by an insulating material, and surrounding this insulating material it will be provided with a protective sheath. So this is the structure of any cable. So in the cable we have a conductor at the center, and this conductor will be protected by means of a insulator as well as a protective sheath. So here this is one part of the capacitor, and this acts as the other part of the capacitor, and when we connect this through a voltage source, this gets charged up. So by means of which it acts as a capacitor, so by means of which it gets charged when we provide supply voltage. And here too, instead of uh, for the purpose of charging and discharging, here too we make use of a switch arrangement. So after it gets charged, it is then disconnected from the source, and at every time instant we measure the voltage across this conductor, voltage across this insulating material by means of a voltmeter. So in the same way as we have discussed earlier, we can able to make use of the same method for measuring the resistance of this cable also. And here the voltage, and here the equation changes as V2 equal to V1 into e power minus 3 divided by C into R. So these two voltages we should be able to find out using this voltmeter, and T is the time duration which we have to measure. And for this, to see the value of for us. So normally in cables, the capacitance value of the cable would be represented by the manufacturer itself. Suppose if it is if it has to be measured, we can even measure it using various methods that we can adopt for measuring the capacitance value. After finding out the value of capacitance, substitute those values, we should be able to find out the current which is this is about the loss of charge method. So this is how we can able to measure the higher resistance values. So if you have any queries or doubts in this topic, please post me in the comment section. I will try to solve those doubts. So for more videos, keep watching. Please subscribe and share. Thanks for watching.